Hey guys, it's AxiomaticUncertainty here, and I'm back with another video. And today I'm just going to be going over briefly this um, poker hand evaluator that I built over the past weekend. So I'll just run through basically a quick demo, and then I'll go through some details about how this thing works. So let me first do a build. So you can see I have a build script here. Just run cmake with release mode with debug info and you know, generates this build folder. Um, and this will create two tasks, one of which is for running tests, and then the other one of which is for running the primary executable. Now, like, the tests are pretty much just functions with some simple logging to verify that things are working correctly for sort of smaller unitary components, but that's fine. And then the main flow doesn't really have a command line interface or anything. It just kind of runs some, engine for simulation. But yeah, let's build this, and you can see it generates a build folder and then generates the two tasks, right? So first, what I can do is I can run the test task and show you sort of what that's doing, right? So this is the test task, and you can see really what this does is as I was going through this process, I created sort of a lot of different tests, right? So these do like outputting of cards, outputting of a deck, right, to verify that shuffling and things like that are working correctly, right? So you can see that's generating a bunch of output. Um, and then I started doing sort of like, okay, generate a deck that doesn't have anything in it. Um, Test the evaluation of like certain hands, right? So see like, does this correctly check whether or not, does this, evaluation function check whether or not I have a flush correctly? Um, and so on and so forth, for all the different things, and then all the way down to like picking, what's the overall best thing I can make with this hand, what's the winning hand of a set, and just basically all the stuff you would want in order to do this kind of evaluation. Um, so yeah, that's the test function. That's maybe the less interesting part, but for the main function, which this is basically not fleshed out at all, um, we have sort of like two things that are really interesting here. We have this all combinations, then we have H2H. So these both let you set a number of players, so a table size. So I could say like this in this simulator, basically I can say like I'm playing head to head, right? Two players, and I have, a pair of aces, right? And if I run something like this, you'll see like, let me switch this to H and rebuild this. If I run this, you will see that the odds that I get match up with, I guess, what you would expect, which is around 85% win rate for this. And you can see it did 500,000 simulations, so the code is relatively performant, I guess. Um, and if I choose sort of like a larger number of players, like say 5 people, you'll see if I rebuild this and I sort of rerun this one, right? The number of one hands you can see is like decreased significantly, right? But pocket aces are still winning the majority of hands even with a 5 player table. If I go up to 6, now this becomes the minority, or I guess the probably more accurately the plurality of games that you're winning. But yeah, obviously really strong hand, and these match up with the statistics you'll see online if you Google this stuff. The other thing that I programmed here is sort of all combinations, which predictably goes through basically every combination of, on and off suit cards, right? And generates basically the overall simulation results for all of these combinations, right? So it'll go through every suited combination, every unsuited, and I can run this one as well. So let's say, again, similar to the other one, let's say heads up, um, suited, off suited, just run everything, and we'll do it 100,000 times like I have here, because 500,000 takes kind of a while, and you'll see it'll kind of spit these out fairly quickly as I run this, right? So you can see, just sort of going through, it's spitting out all of these suited results. So you can see, like for example, 2-3 suited is relatively an okay hand. It loses the majority of the time, but obviously, if I compare this to let's see, the offsuited results for 2 and 3, you can see it's quite a bit better because of the potential we're straight. You can see king and ace suited is probably the second strongest hand, except for some of these high pairs, right? So you can see pocket pairs pretty much are consistently better um, than like almost anything else. Now I don't know if like some of these results change if you increase the number of like total hands. But you can see, like, for example, King Ace offsuited is a fairly strong hand. Pocket Kings are strong. Pocket Queens are obviously strong. And yeah, it just creates all these results. Um, so now I guess I can go through the actual logic for each of the sort of primary classes. I'll skip over the cards themselves and instead go through like the deck and the simulation stuff, since I think that's the meat of like what's really interesting here. The deck is pretty simple. It supports a constructor that allows you to remove cards explicitly, which is useful for if I want to say these are the cards that have already been dealt, or these are the cards in my hand, right? I can construct the deck and just omit those. It supports a shuffle function, which just, takes the cards and goes through and uses random device with the random engine to shuffle the set of cards. And then, it supports a view that returns like a non-copied span over all the cards, which this could be const, I suppose. Um, and yeah, this basically lets you, take all of the like random access into the cards and say like, um, basically these are all the cards in the deck. These are, um, basically being simulated as being dealt to the other players and so on and so forth. And you can see the Monte Carlo simulation then kind of uses a lot of this, right? So you can see, let me first go to the hands. What I've built for hands was this like evaluation thing, which can basically store a type of hand evaluation result, as well as a context which can store information about like kickers and other stuff for comparison's sake, and then also a hand, right? And this hand has sort of like it has some kind of interesting data structures. I tried to think about how to optimize this a bit, and one of the things I realized was while it is useful to store whether or not I have a given like card, it's also useful to store things like how many basically equal face value cards do I have? How many equal suit cards do I have, right? These allow you to basically compute here, across all suits, do I have a straight? Across all face values, do I have a flush, right? You can compute these, as you add cards to this hand. And, given this bit of logic plus like um, some helper functions to determine basically like what it is that I have and what the values are of certain things. Like for example, what are the sets of pairs that I have would be returned by this sets function. Um, and some mechanics obviously for the other things I just mentioned. We can combine these results and do like an ordered construction of all of the qualities of hands, right? So I can evaluate, do I have a straight, do I have a flush? If I have both, I can check for a straight flush, right? I can check which sets I have and say, if I have four of a kind, here's a quad plus a kicker. If I have triples, right, and I, potentially have a pair, then I can say, okay, this is a full house, flush, straight, right? Just all of these sort of in order get evaluated through this. And this code is on GitHub if anybody wants to take a look at that. And then the Monte Carlo stuff, as I mentioned. So you can basically say this is the starting hand, this is the size of the table, so number of players being dealt to, and then the number of executions I want to do. And this does Monte Carlo simulation, so what it'll do is it'll go through and basically take the hand, the table size, and the runs and use all of these parameters to execute a bunch of simulations and generate a probability. So takes these cards and inserts them into the deck as the omission and constructs a deck that basically leaves out these cards. Um, Generates aggregate results. Oops. generates aggregate results through all of these simulations. So you can see we have an iota that just goes through each of the runs that we specified up here. And for each of these executions, we'll shuffle the deck. We'll view the top set of cards that we would need. We will basically simulate dealing these cards to all of the players. And then the last set of cards that you have, basically the last 5 cards from this span that was returned by viewing, get used basically as the flop, the draw, and the river. And together, then we can evaluate all these hands in sort of like, just an iterative fashion, compare them to, um, the hand that the player has, right, which would be the sim hand, and say basically, does the sim hand beat all of these? And if the sim hand beats all of these, then that counts as winning the hand. If it loses any of them, that counts as losing the hand. And then we return the results. So this is how the Monte Carlo simulation works. It's honestly not very complicated. And then to generate all these combinations, like I mentioned, we just kind of iterate over all of the possibilities for suited and unsuited cards. And yeah, that kind of just gets the job done on its own, I think. When we're running unsuited, we can consider pairs. When we're running suited, obviously we can't. And since these results are symmetric, you don't need any additional sort of like looks at other combinations of suits. It's just suited, unsuited to get all of the results. And yeah, I guess this was sort of a bite-sized video about this project, but I thought it was a fun project. I thought this would be an interesting one to share. There will be a GitHub link in the description since I've already posted this on GitHub. And yeah, that's it. Thanks for watching, I guess.